here we have what I think is the simplest way of tying a two-threads knot. In this grid we have, well, above are the bytes, in the columns are the bytes, and in the rows are the leads. So at the left, on the left side of the diagonal, there are the square knots with 1 byte more than the lead, the number of leads. Each knot is tied applying the left expansion to a smaller knot, two numbers smaller knot. For instance, the 10 leads 11 byte is tied applying the left expansion to the 8 leads 9 bytes, tied applying the left expansion to the 6 leads 7 bytes, so on, until we get the 2 lead 3 bytes. The 2 lead 3 bytes is 1 lead 1 byte with an overhang. The same happens at the right side of the diagonal. All the knots, these square knots, are tied based on the smaller, two numbers smaller knot than the desired knot. For instance, if we want to tie the 13 leads 12 bytes, we apply the right expansion to the 9, to the, if this is the third, if we want to tie the 13 leads 12 bytes, is tied applying the right expansion to the 11 lead 10 bytes, and so on until we reach the 3 lead 2 bytes. So we are getting two numbers 2, 2, 2, 2, 2. Another way of tying is the series of leads. To tie a 2 lead two-threads knot, we have to apply an overhang knot to the 1 lead 1 byte knot. So with 2 overhangs, we apply it to the 1 lead 1 byte, we'll get the 2 leads 5 bytes. Another overhang knot will get the 2 lead 7 bytes, and so on. For the 3 leads, we must we have to see that there are 2 knots between the impossible two-threads knots. When they have a common divisor, they are not two-threads knots. So we can we can tie the 3 lead 1 byte, will be this one. Then we make a right over left when we have tied two turns before closing the knot, going to the starting point. We make a right over left, and with the third lead we cross the buttonhole we created with the right over left movement. If we make another right over left, we'll get the 3 leads 7 bytes. if instead of we start with the three lead 2 bytes and apply left over right, we will get the three lead 5 bytes. Another left over right will get the 3 leads 8 bytes. So we see that we are jumping two numbers between each other. Or 3 we will get at the third one. So with the third 3 leads 1 byte and right over left, we will get from 4 to 7. And we apply the left over right at the 3 lead 5 byte, we'll get the 8 byte 3 lead Turk knot. Well, I can make an enlargement here, because down at the we have the formulas that we have to apply to in the column with a constant number of bytes. This one is for the 1 byte, this formula is for the 2 bytes, this one for the 3 bytes, 4 bytes, and so on. And at the right side we don't have anything more. So in another video I'll explain all this grid with the easiest way of tie any knot, any Turk knot. So goodbye.